In this video, we're going to look at the law of signs. However, we're going to focus on what's called the ambiguous case. And the ambiguous case comes to us when we are given one angle and two sides to solve for any oblique triangle. The reason that the ambiguous case is there is because whenever we have a triangle, and I'm never the best at kind of drawing it, so I'm just going to explain it. We could have a triangle that has, well, I'll just give it a shot. But anyway, so we have a triangle that may have a length, and then we have a specific angle, right? I don't know, we'll call it 63 degrees. Well, we could have multiple triangles that have that type of setup. We could have another one where maybe, this was 12, this was 13, so 12 and 13 and 63. So a couple of different triangles could exist where that third side is a different length and the angles are different. So that's the ambiguous case. So this video is going to focus on giving you guys the tools needed to be able to solve those. I'm going to jump straight in. We have three different cases that we're looking for because we could have no triangle existing, one or two. So without further ado, let's just jump straight into it. So in this first triangle, or this first example, they give us the measurement of angle A equaling 108, with side A equaling 33 and C equaling 18. So my first step is to just draw a triangle. It does not matter how we label it. Even if it's not necessarily drawn to scale, some people would be like, oh my gosh. But to be completely honest with you, just for time's sake, I know that angle A is going to equal 108 degrees. Side A is always directly opposite of angle A. It's going to be 33. And then side C is 18. So what I want to do is I want to use my law of signs to solve for angle C. So I'm going to say 33 over the sine of 108 equals 18 over the sine of C. Then we just cross multiply, and that gives us 33 times the sine of C equals 18 times the sine of 108. And then once we get past here, I'm just going to divide everything by 33. So that gives me the sine C equals 18 times the sine of 108 over 33. And the way that we solve for C here is I take the inverse sine of both sides, which gives us this here. Once I plug that into my calculator, we're going to wind up getting out the measurement of angle C, which is 31.2 degrees. Now, this is kind of where it gets really important. So when I get out my angle, if this angle that I got is less than that original given angle, so I'm going to write this out. If my found angle is less than my original given angle, only one triangle exists. And that's it. So if the new angle that I found is less than my original given angle, only one triangle exists, and I'm done. I can, then solve for angle B by doing 180 minus 108 minus 31.2. That'll give me the measurement of angle B, and we could solve for that side B, depending on what the question asks. So that's the ambiguous case there, or checking for the ambiguous case, rather. The ambiguous case is when we wind up with two triangles, which we will see in just a few minutes. So that's example one. I'm good to go. That's it, solving for the side. So example 2 now asks us, or gives us this information. So we have our triangle. We can say A, B, C. Again, it doesn't matter where we place anything. So the measurement of angle B will be 100 degrees. Side B is 27. Side A is 38. So maybe they're going to say solve the triangle. Okay, well, I know that when they ask me to solve the triangle, they want me to find all of the angles and all of the sides. So again, I'm going to take what I have. So I have 27 over the sine of 100 equals 38 over the sine of A. Cross multiply. It gives me 27 times the sine of A equals 38 over the sine of 100. Oh, I'm sorry. It gives me 38 times the sine of 100. Divide everything by 27. So I get the sine of A. Actually, let's do this. So I get the sine of A equals 38 times the sine of 100 over 27. The way that we solve for A is I take the inverse of sine of 38 times the sine of 100 over 27. And something interesting is going to happen when you plug this into your calculator. You're going to get what's called a domain error. Or maybe your calculator just says error, or it tells you something is wrong. Well, when you get this, that means that no triangles exist. And here's the reason for that. I don't draw my triangles to scale because I'm just kind of drawing them for the speed of the problem and so forth. But if I have a triangle where angle B is 100 degrees, we know that that's obtuse. Well, that tells me that the side across from angle B must be my longest side. That's just triangle properties right there. Your longest side is always going to be across from your widest angle. Well, if I'm looking here, 38 is much longer than 27. I can't have that. That's impossible. That would look like a triangle like this. You know, it wouldn't even be connected because you'd have one length out here way longer than the other. So that's impossible for us to have. Therefore, no triangles exist. So again, if you get a domain error, it means that no triangles exist. Another quick way to check is just make sure, oh, okay, if this is my longest angle or largest angle, is my longest side across from my largest angle? If not, again, no triangles exist. And our last example. And maybe here they want to know, state the number of triangles and solve for all angles. So we have our triangle again. I have A, B, C. The measurement of angle B is 60 degrees. B equals 32 and A equals 34, side A. So again, I'm going to set it up the same way that I always have. So I have 32 over the sine of 60 equals 34 over the sine of A. Simplify that out. I'm going to kind of condense some room here. So the sine of A we know is going to wind up being 34 times the sine of 60 over 32. I'm going to take the inverse of that. And when we do that, that is going to give us 34 times the sine of 60, 32. 66.94. And so we'll call it 67 degrees. Now, because our newfound angle is greater than our given, that means that we have two triangles. And here's what I must do. I've got to redraw a triangle, A, B, C, and I'm going to label it the exact same way that we labeled that first one. They gave us 60 degrees, 32, and 34. And now, to find the measurement of angle C, what I have to do is I have to take 180 and subtract what angle I found the first time. What I'm doing is I'm finding the supplement to that angle. And so 180 minus 67 gives me 113 degrees. And so now what I can do is I can solve for all the other angles by simply taking 180 minus 60 minus 113. And angle A here gives me 7 degrees. And then up here, we do 180 minus 60 minus 67. Minus 67 gives us 53 degrees. And then from here, we could solve for that missing side if we needed to, or solve for all the angles, all the sides, whatever the question's asking us to do. So this right here is the ambiguous case. We wind up with two triangles existing that may have same measurements for the angle side, but different measurements for the rest. So I hope this video made sense. If you need some help on the law of sines, check out my other video going over the law of sines for the basic stuff. And then otherwise, check out the next video for the law of cosines. Thanks for checking the video out. I'll see you guys next time.